Hello everybody, and welcome to part 6 of my FTC programming tutorial videos. In this video, we're going to write our very first TeleOp program. Now, I don't expect you to have remembered everything from all the previous videos that I've done up until this point, but we are going to start applying some of the concepts that I've talked about now, and you should have kind of a general idea of what this program is going to look like if you've at least watched the second programming video that I did in this series. But I don't expect you to have remembered everything. I'm going to go through and we're going to actually write out everything that we need to build out a tank drive program from scratch. And then in the future, we'll kind of adapt this program to more and more advanced things. We'll include mechanism drive and some additional like ARM controls and things like that. All right, let's get started. So the very first thing we need to do is we need to identify this as part of a package. Now, all that means is we're telling Java where this file is in our project. Now, if you've done everything correctly, this file should be sitting in the team code folder of your FTC robot controller source code. So that's going to be in org, first inspires, FTC team code. Now, obviously, if you have it in an additional folder in team code, like if I had this in examples, it would be like that. But I don't for now, so that is all that looks like. Now, in this particular program, we're going to need 3 import statements. We're going to need to import DC motor simple, and then we're going to need to import... Hey everybody, future Brandon here. I just wanted to say that I actually made a mistake in writing out this import statement. I misspelled Qualcomm, so it should be Qualcomm, not whatever the heck I did before. Anyways, carry on. Import TeleOp and linear op mode. So for DC motor, that is part of the hardware package. And for TeleOp and linear op mode, they are both part of event loop. Event loop, op mode, and then for TeleOp, it's going to look something like that, and then linear op mode is going to look something like that. So now we have everything we need in order to write out our program, believe it or not. 3 import statements is really not that many. It'll get a lot worse in the future. So the very first thing we need to do is we need to identify this program as a TeleOp program. Now I'm going to give it a name. As I mentioned before, you don't have to do this. You can just leave it blank and it will name your program whatever the file name is, and we'll talk about that in a second. But I'm going to give it a name. I'm just going to give it a basic tank drive. All right, now that we've done that, the next thing we need to do is we need to create our class outline. So public class, and then the name of the class has to be the exact same as whatever file you're writing this in. So since this file is called tank drive, I have to name this class tank drive. If you don't do that, Android Studio is going to get mad at you, and you'll observe that. And this class is going to extend linear op mode. Did I do that correctly? Extends, of course. All right, so now we have our class that is inheriting from linear op mode, which just means that we have all the functions that we need to actually run our program. And now we need to make the entry point for our function, which is going to be run op mode. So this is the entry point for our function, for our program. This is where everything is going to start from. And if you remember in the second video, the very first thing we have to do is we have to acquire references for all of our hardware, because you obviously can't do any controlling of the hardware if you don't have reference to it. I don't know if that's something that everybody remembers or not, but it is still the case. Excuse me, I am messing up all of my keybinds. All right, so we need to make a bunch of DC motor simples. So since this is a tank drive, I'm going to assume standard configuration of the wheels, which means there's going to be 2 on the left and 2 on the right. All right, so one at a time, we have to acquire and name each of our motors. So I'm going to do left motors first. So left front, left back, right front, and right back. Now you don't have to name your motors the same way that I do. You can obviously name them however you want, but I am going to name them like this. I'm also going to assume that they're named the same in our robot configuration as they are. Excuse me, I keep hitting the wrong buttons. I'm also going to assume that they are named the same in our robot configuration as they are in our program here. So I'm going to assume that everything in your robot configuration matches exactly what I have here, and I'm just going to name all of our motor variables the exact same. So now that we have that, we have successfully acquired reference to all of the motors that we're going to be running. Now we have to set the direction of them to make sure that their forwards is forwards for all of them. In this case, I'm going to choose to reverse the left side motors. So if you remember, what that looks like is .set direction DC motor simple .direction .reverse. So now that I've done that, oh, hold on. I want the left side. I don't want the back. Okay, perfect. Now we have successfully set the direction of both of our left side motors to be reversed. So now forwards for all of our motors should be forwards. Obviously, or maybe not obviously, this has the potential to be different for different robots. So kind of play around with it and see if reversing the left side motors works for you, or you might have to reverse the right side motors, kind of depending on which side you want your forwards to be. So now that we've done that, we've done everything that we need to do before the start of our program. So now we're going to call our wait for start function. So this function is going to pause our program. So at this point, we've successfully hit initialize. All of our hardware has been acquired. All of our motors, drive motors, have been acquired. And we have successfully set the direction of our left side motors to be reverse. Now we're waiting for whoever is the driver to hit the play button. Once we do that, we are going to write what's called our TeleOp loop, or while op mode is active loop. And this is just a section of code that's going to run continuously until you press stop on your driver station. So while op mode is active, and now any code that we write inside of these brackets is going to be run continuously as fast as the program can run it until we press stop on our driver station. So we need to do this so that we are constantly acquiring values from the controller and constantly updating powers on the motors. If we don't do this, we're going to do it a whole one time before our program finishes, and we don't want that. We want our program to continuously run. So like we discussed in the last video, we need... Actually, don't know how I just did that. Cool. That's fun. All right. We need two things. We need our... we need both the values from the left and the right sticks on the controller. So in order to get that, I'm going to call gamepad1.leftStick, and we're going to get the right stick as well. All right, so now we have successfully acquired the gamepad left and right stick for this particular loop. Now, this value is obviously going to change, like, I don't know, once every 5 milliseconds, and these values will be updated every time our program runs through the loop again. And the loop times can vary quite a bit. In this very simple program, it should be 5 to 10 milliseconds. In some more advanced programs, it'll get a lot longer than that, but that's about what I would expect this particular program's loop time to be. All right, so now we have to actually set the powers for all of our motors. And in order to do that, we are going to do .setPower. So if you remember from previous videos, this value can be a number from -1 all the way to 1, and wouldn't you happen to know it, our ly and ry double values from the gamepad are also going to be from -1 to 1. So this works out perfectly. We can use the left and the right stick values for our motors. So I'm going to set the left front to the left value. I'm going to set the left back motor to that value. I'm going to set the right front and the right back. And believe it or not, we are done with our tank drive program. So just to reiterate, we are importing, first of all, we're identifying this as part of a package just so Java knows where to find this file and where to access it. We are importing DC Motor Simple, TeleOp, and linear op mode, which we need in order to build out our TeleOp program. We are identifying this class as a part of TeleOp, and we're giving it a name. Don't have to give it a name. If you don't want to give it a name, this is what that looks like. We are creating our linear op mode tank drive class. Please note that this keyword, or this is just the name of your class, has to match exactly with whatever your file name is. Android Studio will get mad at you if you don't do that. It'll become very apparent. We are creating our entry point for our function, for our TeleOp program, which is run op mode, so that'll happen whenever you press the play button on the controller. We are acquiring reference for all of our drive motors from the hardware map. We assume that everything on our robot controller is named with the same semantics, so right front, right back, left front, you get the idea. Then we set the direction of our left side motors to be reversed so that forwards for our robot is forwards on all the motors. You may have to play around with this depending on your particular robot build. You may want to reverse the right side motors. Then we call wait for start, which is just going to pause our program until the driver actually hits play on the driver station. Then we initiate this while op mode is active loop. We need this section of code to run continuously until we decide to stop it by hitting the stop button. And all this code is going to do is it's going to get the values from the left and the right stick of gamepad 1, so how far we're pushing the left stick up or down, how far we're pushing the right stick up or down, and then we're going to set the powers of our motors to be equal to whatever that value was, so anything from -1 to 1. And that is a complete tank drive program. Now, if I went too fast, feel free to rewind and rewatch portions of this video. I tried to do my best and write the whole thing from memory, but as you can see, I had some problems with key buttons and things like that. I hope I did an adequate job. If you have any questions about this program, please let me know. And in the future, we'll start talking about how we can adapt this program into a mechanism drive program and how we can start doing some more advanced, little nuanced things to make this program better to run for our drivers. So let me know if you have any questions, and I'll see you in the next one.